Thanks for attending today. If you could please confirm that you can hear me and that you can see my slide deck. Okay, very well. Thank you for confirming. We'll go ahead with the presentation. Thank you. So we're continuing the series, Reactive DDD. Today we're going to talk about, of course, mainly just a technical topic, reactive storage, and we're going to show you three flavors of the vlingo reactive storage. So let's get started. Again, I'm the Reactive Platform Chief Architect. I founded the vlingo platform project a few years ago, and we've been making steady progress both in Java and on .NET. If you're a .NET developer, I encourage you to check out the .NET edition at github.com/vlingo-net. Otherwise, you can see the Java source code at github.com/vlingo. And I also encourage you to look at the vlingo.io website. So later today, we'll be releasing version 1.3.0. This is the Java release, and it will be available on Bintray, Sonatype, and Maven Central. Whenever we do a release, by the way, the initial availability is through Bintray, and shortly after that on Sonatype. But Sonatype's replication to Maven Central can take 4 or more hours to complete. So if you would like to see the next release more quickly than Maven Central has it available, then you can usually find it on the other 2 repositories and for sure on Bintray. So again, reactive is message driven. And today we'll be looking at the message driven aspects of persistence, and we'll show you 3 different kinds of storage engines that we support, and from an abstract point of view, and I'll also show you some information about how the databases are created, at least from a SQL table standpoint. Of course, these would have a different layout or composition if using a different storage engine other than a relational database. So by the message-driven characteristic, we're also this week going to discuss how the storage is responsive, and when a cluster, for example, a vlingo cluster through vlingo lattice scales out into a cluster, then we remain responsive even across cluster nodes, because of each node will have its own context to the persistent storage. If you were with us last week, you saw that vlingo supports 3 different kinds of storage. We have the ObjectStore, the StateStore, and the journal. And notice there that the ObjectStore and the StateStore both have an associated journal. This is not exactly the same as an event source journal or event sourcing journal, but they do nonetheless have journals, and through this journal, the ObjectStore can atomically persist both the state of the entity, that's the smaller circles above the storage mechanism that marked with E for entity. So the ObjectStore can store both the state of an entity object and any domain events or other kinds of sources that it may want to persist in the journal. The StateStore likewise can store atomically the state of the entity and also any domain events, and again, any other kinds of source types that you may want to have associated with a given state. So this is where we meet, where DDD modeling and persistence meets. The storage engines that we support currently are DynamoDB, Apache Geode. JDBC drivers include Postgres, MySQL, MariaDB, Yugabyte, and HSQLDB. And in case you haven't heard this before, our Yugabyte compatibility, or that we use, is the Postgres compatibility. So we can use a regular Postgres driver, JDBC driver, to have an interface to Yugabyte, and through Yugabyte you get global scale in persistence, and that includes atomic transactions. And soon we'll be releasing fast scalable journals, and you'll see success with those very soon. Let's first go through the object entity and the kinds of storage that it supports. So the object entity is the abstract base class that you see the rate entity is extending here. And the rate entity may emit both a new state and one or more domain events. The object entity abstract base class then handles the interface to the object store. Now, there is no persistence looking interface in the object entity. What you actually do with your domain object, your entity, is you simply use a method named apply, and there are various overrides to the apply method, and the apply method is where you apply new state to yourself and any domain events that have occurred. And then after the object store has persisted these atomically, then the rate is told that its state can now transition to its next valid state, because we're guaranteed that the entity state is on disk in the database. This is an OR mapping or object relational mapping type of storage. And so you can see in the rates table that this is where the entity state would go. And so you would map your object to the relational table rates. And this could be through JPA, through Hibernate, and we support a thin interface called JDBI, where you can map fields directly using a SQL expression. And then also at the same time, if you're emitting any domain events, those will be persisted atomically along with the state of your entity. So this involves writing some sort of a code for or configuration for OR mapping. And if you're, I'm certain, already familiar with JPA and Hibernate, you pretty much know what's involved there. And given that the rate entity is an actor, generally speaking, when we're talking about persisting state, we're talking about persisting a separate state object, because you really can't persist the actor itself. And so internally in the actor, there will be one state type. So for example, we could name it rate state, and that rate state can be, for example, a POJO, even a bean, and you can set properties on the bean, which could be annotated with JPA or Hibernate, or you could have a Hibernate XML mapping, same with JPA, and whatever your mapping type that or flavor that you're using, that will be used by the object store to map in. So let's take a look at the interface for the object store, first of all, to persist. And I just want to mention that this persist method that you see here is sort of the richest persist method that exists. There are other persist methods that, for example, may not take a sources type or may not pass an object, this final object. I'll explain that in a moment. So if you look, you can simply actually persist the persistent object, which is of type T, that is passed in as a parameter. The T type is passed in, and you can persist that with, for example, only an interest, and the interest is basically a callback, but it's not, it's a message back. So from the object store actor that you're actually using for this persistence, it will send the message back to the persistent result interest, which will tell it that there was a successful persist that occurred or a failure. And then the object that is the final parameter there is an object that will be passed back. If that object is provided, it will be passed back with the interest, and therefore you can have basically some correlation to the persist that you've just requested through a message. Also, you can see that you have the option of sending in a number of sources. Generally, it would be just one, but it could be 2 or more sources. And these sources, the source type is the base type of a domain event, for example, or of a command, because you can also persist commands. And persisting commands is important when you're using, for example, a process manager or a Saga. So any kind of source can be persisted atomically along with a persistent object. And then we also support persist all, which means that you can persist any number of persistent objects simultaneously with any sources that may be included with that persistence. And this works the same way as the single persist, except atomically you can persist multiple objects at the same time. Now, I want to just mention that the single persistent object persist method works in the way that you would use typically for a DDD aggregate. If you are not using the aggregate pattern, then you could persist multiple objects simultaneously, but for a DDD aggregate, you're encouraged to use just a single persistent object in a single transaction, along with any domain events, for example, that it may support. Another use of persist all is when you are creating a new entity for the first time, and maybe you have to create multiple entities simultaneously. This would not be a consistency violation because with a new object, these will always be unique, and therefore you can persist multiple new objects simultaneously. And again here, just adding actually one more, the interface for the callback or the message back on the persist result interest. So you can see there that persist resulted in method is sent back to the sender of this message. So this protocol persist result interest, for example, would be implemented on a class and then you would provide your own actor as an instance of this kind of interest. So for example, the object entity in Lattice, this is the abstract base type of any OR mapped entities. the object entity implements this protocol. And that's how we interface in your behalf to the object storage. And the outcome that you see there is sort of like a functional outcome. So we don't throw exceptions. If we have an exception in the storage mechanism, so for example in the object store, then we will pass back as an outcome a storage exception or a result. And so this is sort of an either kind of monad in that we're passing back, and that is what the outcome is. And then you'll have an instance of the persistent object itself, and any, what were the possible number of objects that were going to be persisted. So for example, with the persist all, and the actual number that were persisted. And so in that case where possible is greater than 1, then the persistent object, pardon me, is actually a collection. So you could cast that to a collection. And then the object is the message back object that is related to this specific request for persistence. To query, you use a query expression, and using a query expression, which is provided by vlingo Symbio, the component that sort of defines the object store, the state store, and the journal types. This query expression gives you a way to abstractly provide an expression for any kind of database. In this case, it would be an SQL or SQL expression to query all of some type. And then the query object method would be an expression that would result in a single object being queried out of the object store. Now, when it comes to the table definitions, of course, these table definitions are according to whatever your domain model type is. So I can't give you an example of what this would be, but you can well imagine that you have a column for each field in your state type, and these would be mapped using the OR mapper. So I do provide examples of the tables that table definitions that we have for the state store and the journal, but in this case, this is completely domain specific. Let's now look at the stateful entity and the state store. This is where a rate, in this case, extends the abstract base type stateful entity. And so the stateful entity will store according to a key value pair. That means that the business identity of the rate, so the global unique identity of the rate, will be used as the key, and the serialized snapshot of the current state of the rate is what will be persisted as the value. And you can see there that we can still use a rates table, but in this case there is not a column for every field in the rate state, but rather that will be saved as a clob or blob kind of storage with either characters or bytes. And of course, we still have a journal table, which is how the rate is persisted, or any domain events that are associated with the rate are persisted. Okay. So let's take a look at the writer interface. So there is a parent interface, or the highest level interface, which is named StateStore, but the StateStore simply extends the two protocols or interfaces, StateStore writer and StateStore reader, and I'll show you the reader in a moment. So again, this write method is the richest write method that exists in the StateStore writer. You have other methods that don't contain as many parameters. So at a minimum, you must provide the ID or the key for the right to occur and the state, and basically just the right result interest. But in addition to that, or actually, no, you also have to pass the state version, which is the version of the actual data that's being passed in. And you can also additionally pass in sources. That is, again, one or more domain events or any other kind of source. And you have the opportunity to pass in metadata as well. And I think I failed to mention with the object store, but you would have to provide your own metadata column if you wanted to persist metadata, and that would have to be included along with the object. Okay, so you can see how this would work. Now, the state version is important in this case because if you have to migrate a state, as in upcast it to a newer version of the state type, this state version is how you would take care of that. And along with vlingo Symbio and all of the storage types, the 3 flavors, you can create what's called an adapter, which adapts the stored type to the in-service type, or the type of your domain model. And you can also adapt from your state type to the given type that will be stored in the database. So this adapter is registered with the StateStore prior to performing any of these operations, and the StateStore uses those adapters if they exist. If they don't exist, you get an automatic default adapter, which basically, for example, would adapt your state object to a JSON object, and the JSON object as text is stored rather than the state itself, which is pretty much how it has to work. In the StateStore reader, the reader, with the reader, you read by passing in the type, the key, which is the ID, and the type, and this is what tells the StateStore reader what type to expect when it reads. And for example, when you are reading a given type from the database, or when you're even writing it, for example, in the relational database or JDBC version of it, there is a different table for every type. So we expect that all, for example, product states, for example, would be written into the products table, and so forth. So this is why the type is passed in, and it also means that we use the correct type to restore the state inside the reader and pass that to the interest. You can stream all of from the StateStore reader. This is using reactive streams, the vlingo streams component. So you can query all of a given type, for example. So this would scan or actually query from the entire table of a given type. Or you can also stream a partial result, as in perform some query that is in the query expression, and the results of that query would be streamed through the stream type, the reactive stream type, using vlingo streams. Here's an example of the StateStore table. This table can be named, whatever is the name that is chosen by the implementer or the user of this. And so you see that that parameter to the table name. So this table name would typically be called, for example, vlingo StateStore, and then some type, as in products, table. The identity is a varchar of 128, so you can have up to 128 character keys. The type, this is the state type. So for example, the fully qualified class name of the entity state type. So for example, product state has can be up to 256 characters, and then the type version is an integer that says basically this is the version of the type. So the type may be version 1, version 2, version 3 of that type. So for example, product state could go through any number of transitions. Now, in the case of a relational database, it might be easiest to migrate the tables themselves rather than doing an on-the-fly migration. And so you have that option as well. Notice that the data type of the column is sort of optional here. This would be either a clob type or a blob type. And of course, that differs per database. In the case of some databases, this would simply be, for example, a text type for JSON serialization, for example, or some other binary type if you were storing bytes, as in raw bytes. The data version is now the version that the number of times that this data has transitioned. So is this version 1 as in the very first snapshot of this data, or is this version 93, which would be the 93rd snapshot of this version, and that's what of this data, and that's what this represents. And then your metadata can be basically as big as you need it to be. This is a text type in one of the examples. This would, for example, work with Postgres and MySQL, I believe. And the metadata op is important here because this is the operation that caused this state to be persisted into this particular StateStore table, and the operation can be used as metadata actually to know how to project the full data state into a CQRS query model or read model. So this is interesting, and also what I'm not showing you here is that each table type has a dispatcher associated with it, and the dispatcher guarantees that any persisted state per individual persistence will be dispatched out of the StateStore, and until it is confirmed, it will be redispatched on some periodic basis. And one of the reasons for dispatching would be to dispatch to a projection dispatcher that would take the metadata op type, and you could use that to understand which, or actually the projection does use the metadata op type to dispatch to any given individual projections that want to project this state. For event sourced, again, we have the rate entity, and in this case, the rate entity will by and large emit or apply domain events to itself. The event sourced abstract base type is extended by the rate, and it will take care of interfacing with the journal, which handles streams, and the streams handled would be individual streams for each globally unique identity or globally unique rate by identity, and it also handles an entire totally ordered stream in the journal, so you can read from beginning to end every domain event that has occurred. The journal interface, again, this is the richest append all with. This is where you can append, actually the other methods above this, which are less rich, you can append a single event, or you can append all, which is a list of any number of sources. You provide the stream name. This is the global unique identity of the entity, for example, the unique identity of the rate or the rate state, and then the from stream version means that this is the start version of the next source or domain event to be persisted into the journal, and then that stream version will be incremented for every, for example, domain event that is in the sources list. Here again, you can store metadata. You can also store a snapshot of the state for basically performance reasons. So along with a domain event, you can atomically store the snapshot at that version, which is the starting version. So if you're recovering a large stream of state from the journal, you can first apply the snapshot as the beginning state, and then only read the number of domain events that have occurred since that, and apply those from that version forward. You also have a journal reader and a stream reader. The journal reader is the means by which you read from beginning to end of a given journal. So the first event that ever happened in this service or bounded context down to the last that is currently available, and you can keep that reader open to continue to read as new events become available. And the stream reader is how we read a single stream, such as a unique rate. So when we need to recover the rate instance, a given rate instance with a unique identity, we use the stream reader. Both of these have names. That means that you can create unique readers that so you can have any number of journal readers or any number of stream readers open at any given time. The journal reader just extends the entry reader, and so everybody that provides a journal type, whether it's the ObjectStore, the StateStore, or the journal, has the ability to read from the related journal. So for example, you can read the very next entry, which may or may not exist. You can basically seek to, in the next read next method, you can seek to the from ID. This is passed in as a string, but it's interpreted according to the natural type of the underlying database. And in this case, if we're using JDBC, this would turn this from ID would be converted to a long, and then that long would be used to get the next identity in that stream. And then you can read next a maximum, so you can read up to n, which would be the maximum number of entries provided, or you can seek from ID and then read the next up to maximum entries from that. Now, and then you can also use stream all, which means that you can get a reactive streams of the vlingo streams type back from stream all, and this is how you could stream over the entire journal. And you can do that with back pressure, because you can in your subscriber to the stream, you can tell the publisher how many entries you're willing to read at any given time. These are two of the tables that are supported, for example, in a relational database. So here you can see that we have an overall identity, which is, in the case of, let's say, Postgres, a big serial, which is, a very large number or capable of a very large number. The stream name is the global unique identity of the entity, for example, the rate. The stream version is the basically an index as to how many different events have been written, and this is how you determine also the order in which those domain events should be, for example, played back or reapplied to the state when you're recovering the state. And then, for example, the data in this case is a JSON text serialization. You have the type of the data type of the entry, as in the data type of the domain event itself, and then the entry type version, as in what version of the domain event is this, and then you can persist metadata with it, as much metadata as you need. And then notice the vlingo Symbio journal snapshots table. This is how you persist the snapshots, as in the data itself that is a snapshot of, for example, the rate state or the product state or whatever. And so this is how you can recover more quickly the state of a given entity. I want to note too that any of the journal readers that we provide, whether it's for ObjectStore, StateStore, or journal, all have, if you're using, for example, a relational database, and there is the potential of an auto increment being inserted into the table, like for example, the entry table as a domain event, those can be written out of order, even though the auto increment is provided before any persistence takes place, and there is a total ordering of the auto increment. Actually, this can be a problem because there can still be a race into the database on which row actually gets inserted first. And so you could, for example, have identity 2 inserted before identity 1. So one of the measures that we've taken is we have a gap prevention or gap detection mechanism, that if we see a gap in the identity of a given stream, then we know that we can basically retry until we see the gap close, or if that gap doesn't close within some time frame, then we consider that gap a gap that has occurred, for example, through a rollback or something like that. And actually Petru implemented this feature, as well as a lot of features in vlingo Symbio. And so I'd like to turn the presentation over to him now, and he's going to provide the demo of this. Hang on just 1 second. Okay, Petru, I'm making you the presenter. So you should be the presenter now, and I'm going to turn off my microphone.
Hi, Vaughn. Can you hear me? Okay. Can you hear me, Vaughn?
Petru, I don't hear you. Does everyone hear Petru? Please confirm that you hear him or not. Oh, okay. For some reason I don't hear him, but go ahead, Petru.
Okay. Let me get started. I want to show you at the beginning that we host all our artifacts in the Maven Central, and currently we have about 22 components of the vlingo platform. Okay, let me get straight to the ObjectStore, and as Vaughn explained, the main interface is StateStore, and it extends the ObjectStore reader and ObjectStore writer. So by the way, this is the vlingo documentation. You can check it, and also you can use the Maven Central for downloading the artifacts. Okay, we already discussed that persist and persist all. Vaughn explained them. Let me go back and show you some examples. So this is a very simple example of a state store. This is a unit test. At the beginning, we have to set up the world. The world is a primary container within actors live and play. And then we have two interests, as Vaughn explained them. They are callbacks, but they are reactive callbacks. And we have the dispatcher exactly the way like Vaughn explained. And finally, we are defining an object store. And this, in this case, is an in-memory object store actor, which of course implements the object store protocol. We can take a look at object store protocol, which extends the object store reader and object store writer. And in addition, it adds the close method. Okay, so the initial setup, it's quite simple. The key field to notice here is the object store. Let's see the object store in practice. We use Access Safely, which is a toolkit available developed by Vlingo. It mainly ensures thread safety and concurrency, so that we can receive synchronized information. In this very simple example, we create three persons. Let's check how they look like. They have to extend the state object, and they add a very simple two fields, which is the age and the name. Below down here, we have simple methods from inherited from object. Okay, after we create these three state objects, we can easily persist them, and we use the persist all method. This looks very simple, and we are following up the results in persist interest, which has been already defined. After persisting these entries, we are going to check if they are indeed persisted, and we use the query all method, where we specify the class type of the state objects we are persisting. And we can see in the end that after we persisted the three state objects or three persons, we can check that indeed those are persisted. I want to mention here as well that this code it's reactive. You can notice that by seeing that all the object store methods do not return any value, but we have to subscribe, we have to register for the callbacks, and via the callbacks and events received by the callbacks, we can check the outcome of object store methods. Good. I want to tell you that this is a very simple example, but due to actor nature of this code, this object store can reside on a totally different node. The persist interest can reside on another different node, and also the submitter can reside on another different node. So this reactive code is by design resilient and scalable. Let's give it a try and run this method. Yeah, so it passes. So to sum up, we use the persist all method of the object store, and we use the query all method of the same object store, and we get in return the persisted object. Okay, let me move to the next demo I prepared. This demo is it's about the StateStore, and here we have two tests, but let's start with the setup. If we go and check the documentation, we see that for the StateStore case, an initial configuration needs to be done. It's a bit more complex than in the case of the object store. And we have to register the product store name, and we have to register adapters. Okay, let's go back to the code. Like in the previous example, we have to set up the world. We have to register we have to configure the entity class we are going to persist. But let's see how does it look like the entity class. In this class, it's a very simple plain old Java object. It doesn't extend or implements any of interface or abstract classes. It just adds two fields, which is ID and value. And for very specific reason, because we don't extend or implement any interface or method, we have to implement the adapters so that we can know how to serialize and deserialize the state into the database. Okay, then we have in this case I used an HSQLDB configuration, so it's an in-memory database. We have a delegate, as Vaughn explained in the presentation. And the interesting part is the store itself, which is also an actor. And this actor implements the protocol StateStore. So basically, these are all the methods which are available in the StateStore. Okay, let's see a very simple example. We define three entities, which I showed you earlier with the ID and value. And then we are going to write those entities into the store. Bear in mind that the store is, bear in mind that the StateStore is a key value store, and we have to provide a key for each individual object to be stored. And in this case, we could pick up to be the ID, and then comes the entity. We write those three objects into the StateStore, and afterwards we are going to read those values, and we use the read method of the StateStore. And we can check that the objects have been written successfully, and we can get back in return the object after they were written. This is a very simple example just to show you how to persist into the StateStore entity objects. Now we are going to a more advanced use case where we are going to use streams. In this case, we are storing multiple entities, but in the end, we are going to retrieve them using the stream interface. So this is the stream interface. This interface is available in vlingo streams, and we can register. We have to consume all the entities which were stored into the StateStore by invoking flow into. So basically, all objects will be consumed by this lambda function, and we are requesting at maximum 10 objects in a chunk. And in the end, we can check that those entities with a limit of 200 are indeed stored into, they are persisted, and they are very well written from the StateStore. As I mentioned in the previous example, you can see the reactive nature of the StateStore by looking at the return types. Basically, we don't have return types; it's just void, and we can register later on to receive information from the store reactively, either as we used in the first example, the interest, or in this case just reading those entities, also using the interest, or using directly the stream and using the flow into method so that we can consume all the available entities from the StateStore. Let's give it a try. Yeah, everything looks green and all both tests have been passed. Let me check the status of the Docker image for the third example. Okay, my Postgres database test image is up and running. Let's move to the third example, which is of course journal example. The setup is similar, but in this case we are just creating an actor, which is a JDBC journal actor, and this actor exposes the journal protocol. Okay, and we use from the journal journal reader, as Vaughn explained, as well as the stream reader to retrieve information in different manner from the journal. Let's see a very simple example. We have a test event. Let's see how does it look like. It contains an ID and a number. If we take a look at this class hierarchy, we can see that the base class is source. It is worth to mention here that in vlingo lattice, we have 3 implementations of this source, specifically domain event, command, and process message. And we are using in vlingo lattice this Symbio component along with Symbio JDBC to persist and to store and to retrieve information from persistence. Okay, let's see a very simple example. So we have a test event, which is a complete implementation of the source. We give it a value of 1 and the string of 1. And then we invoke the method append all, and we specified 2 sources we created previously, 2 test events. Like in the other cases, we register in interest. And in this case, we are using the journal reader to read the 2 events we have persisted previously. So in this case, we are using this way of retrieving information from the journal. And we can check that we have exactly 2 entities, and we can check that they are not null. Let's go further to the second example in this test, which is related to the snapshot. We are preparing here 4 test events, and we are saving at the beginning. So we are appending at the beginning first 2 events, And then we are appending second two events, appended event 3 and appended event 4. But in this case, pay attention that we specify a snapshot, an entity. And this entity represents the current state of the stream before the sources are applied. So this entity represents the snapshots before these two events are applied. So basically we have 1, could have been 1, 2, and the number 12. So basically the state of the first two events. We can also retrieve this snapshot using from raw state and specifying the snapshot parameter. And we can check that in this case, the read entity has the same ID like the entity we created initially, basically the snapshot, and has the same number. So we can retrieve the snapshots as well. Let me go to the second way of retrieving information from the journal, which is the stream reader. This case is basically similar with the previous case I showed you related to the StateStore. We just persist here 200 events, and then using the journal reader, we get a stream, and from that stream, we are asynchronously consuming the events, so all the entities, and then put them into the sink. At the end, we can see that the limit we specify, so the number of entities we persisted are read exactly the same, and we can check the limit. Okay, so basically these are the 3 tests I wanted to show you in the journal example. Let's give them a try. Yeah, they are passing. They are not blazingly fast because there is communication with the database. So that's why we have tests which are running in more than 1 second. So basically these are the tests. These are the methods I wanted to show you, and these are the 3 flavors of persistence in Vlingo, which are ObjectStore, StateStore, and Journal. Thank you so much for watching this webinar. I will just hand in to Vaughn so that he can take questions.
Hi, Petru. Are you finished? Can you just reply in the Q&A box? Okay, thank you. So have one question from Dina, and Dina asks, how can I read my own writes? So if I'm an entity and I persist asynchronously, because that's what we're doing, we're persisting asynchronously, how do I get my own state back? Well, this is kind of answered by handling it in a different way. And so let me see here. So this is handled, for example, by, I need to, wait, okay. Okay, I just needed to make myself the presenter again. So In fact, let me roll back a little bit and just show you this diagram. So notice that the rate invokes an apply method on event sourced abstract base class. Just as one example, they all work semantically the same way. All the object entity, stateful entity, and the event source type all semantically work the same. So I apply a new domain event to myself, which is managed by the event sourced abstract base. And then what happens is the abstract base suspends all messages. So we will not process any more messages in the rate entity or aggregate until the journal has atomically persisted one or more of these domain events that have just been applied, including snapshot. So for example, let's say that we emit one domain event and we include a snapshot with that. That will cause the rate to be suspended. Means no more messages will be handled until the journal round trips and says success, right? We persisted both the event and any snapshot state atomically. You are golden. And at that point, the event sourced entity basically unsuspends itself, and just before it does that, actually the rate state is now updated with that new domain event. So for example, let's say that the event is called rate calculated, and there will be the event sourced abstract base type will invoke a method on rate called, for example, apply rate calculated, and it will pass to it the rate calculated event, and the rate will then transition its rate state to the current state. Okay. In that case, you actually don't have to worry about reading your own write, because your rate is still in memory, and that rate object will stay in memory until such time that we have some high memory, high watermark of memory utilization. And if that rate has not been used in some time, as it has not processed any command messages, it can then be evicted from memory to make room in memory for other domain objects as actors. But when that rate is recovered in the future, let's say that a message is sent to that rate and the rate is not currently in memory, we then load that rate dynamically in behalf of the requester that's sending the command, and that rate is then restored from the journal to its current state. Okay, so does that kind of answer your question, Dina? Okay, good, thank you. I have another question from Felix. In the first slide, it stated ObjectStore plus journal, StateStore plus journal. Do I have to create them separately, or do state and object stores already come with an associated journal? Okay, good question. Actually, that's a very good question. I actually have not answered that question before. It seems like you could use potentially the same journal, but I'm going to just say at first no. I would have to look into that because I haven't really thought of that, but typically what you would do is simply have a different journal for each type, or you would tend to use, for example, object entity across all of your entities, although you could have some event sourced entities and some objects entities or some stateful entities. But I would say a more typical approach would be, for example, if you're using event sourced, you would have a separate journal, and then you would, for example, use the StateStore as your read model or your query model, and your projections from the journal activity would be projected into the StateStore. And so in that case, the StateStore would not have a journal, because you would never project domain events into persist those in the journal of the state journal. I don't know, does that make sense to you, Felix? We haven't really considered sharing a journal across multiple types, and I can see why you might want to do that, but I'm also thinking maybe that's not a good idea. Okay, thank you. And the reason I think it's not a good idea, because there is not really necessarily a correlation between the kinds of events that are emitted for the sake of event sourcing and the kinds of events that are emitted from an object entity or a state entity. But if you can show us that there's a need for that use case, let us know and turn in an issue against vlingo Symbio, or yeah, turn it in against vlingo Symbio, and we can look into that. Thank you for the question. Any other questions? So I just wanted to show you that next week we will be discussing vlingo Zoom. This is our boot quick start micro framework, and this is going to include a demo of not only the quick start micro framework itself of Zoom, but also the vlingo Zoom starter, which is a project generator, basically a way to generate your project, including support for Docker, Kubernetes, different kinds of databases and so forth. So this is a really great quick start, and we'll be demoing that next week with Danilo. Check out our support page on vlingo.io. We have both developer support and production support, and these are very budget friendly. We have monthly support, we have annual support, we have team and enterprise package support for developers, and for production support we have a typical 3-node or 5-node cluster as a fixed price, and then enterprise packages for scaling those up or using vlingo in larger clusters or any number of different projects, services and so forth. And also a reminder that I will be teaching half-day workshops starting next week on Wednesday, domain modeling with entities. The following Wednesday is domain modeling with value objects. Following that, domain modeling with aggregates. And then toward the end of April, domain events, message patterns, and safe information exchange. Then in May, I start the really simple series for really simple functional domain-driven design, followed by reactive domain-driven design, and then really simple event-driven REST APIs. So I welcome you to join us in that. And thanks for attending today. Thanks very much, everyone. And we'll see you next week, hopefully. And I think you'll really want to learn about Zoom. It's really an incredible quick start for consuming Zoom. Okay, take care.